Well, that's what I kind of want to know. What is your actually? Can you get more specific on what you're actually doing right now? Because I'm just very, unlike Finian, I
Yeah.
am actually interested.
No, for sure. I definitely can. So, um, and this is like it might be a little bit dense. Um, but so what I'm currently working on are these things called Catalan objects. And Catalan objects is a term for like an interpretation of this very famous sequence of numbers called the Catalan numbers, which are recursively generated. Um, a recursively generated like sequence that you're probably familiar with is like the Fibonacci,
Hmm.
and these are related to the Fibonacci numbers, but they're generated in a different way. Um, and yeah, so they're generated recursively, which yeah, it means that they are dependent on the entries, the indices before them. Um, and they are like particularly dense in terms of study because they have so many interpretations, which is, and all of these different interpretations are the Catalan objects. And particularly the two that I'm working on right now are the ways to arrange strings of parentheses in like sets of multiplications. So if you have like three elements that you're multiplying in only pairs, there are two ways to legally arrange your parentheses around those three objects that will, like, two unique ways. It's basically just recursively applying associativity, the property of associativity to these sets of numbers, or not necessarily numbers, but just elements of a given set. And I am, and those number of ways correspond to Catalan numbers. So the Catalan the starting sequence is 1, 1, 2, 5, 14, 42, 132. Keeps going. I can describe the recursion, but it's a little bit dense. But these sequences of parentheses for, if you have n elements, you will be able to create a, like, you'll be able to generate a number of legal strings of parentheses equal to the n minus one Catalan number. Um, and the related Catalan object that I'm drawing these connections to is something that seems particularly unrelated, but is actually very closely intertwined, and it is the number of ways to triangulate an n-gon. So an n-gon is any like polygon that is uniform. So like
Hmm.
square, triangle, pentagon,
Hmm.
hexagon, etc. All always obtuse angles. And triangulating these is, it kind of self-explanatory. It is what it sounds like. It's like drawing chords from vertices to vertices inside non-crossing chords that divide the shape into triangles. And the number of ways to do that for a shape with n vertices is the n minus tooth Catalan number. So um, a bijection between the ways to arrange these parentheses around elements and the ways to triangulate different shapes.
Wait, can I just real quick? So with that, like if you had a square and you put a
Mhm.
diagonal line, that makes two
Yes.
triangles, which is n minus two, four sides for the square. Is that what you mean, or four vertices for the square?
So
Is
yeah,
that
so
is that the correct interpretation?
what I mean is that, so if you think about that, you have that square and you can draw the diagonal from like the top right to the bottom left.
Hmm.
Mm-hmm.
So that's one way to triangulate a square. You can also draw the diagonal
Oh,
from the, whatever, the, I forget which one I said, but the other
Yeah, the
diagonal.
top left to bottom right.
Yeah, exactly.
that's what
So
it
there are
describes.
two
Okay.
ways, yeah. And for a pentagon, there are five ways to uniquely triangulate
Okay.
that pentagon.
So it's not just the number of sides, obviously, but it's somehow related to it's the number of ways to triangulate an n-gon is, so whatever n is, it's you take n minus 2, and that number in the sequence of the, what's it called again?
The Catalan
The
numbers.
Catalan. That is the number of ways to triangulate that n-gon.
Yes, exactly.
Okay, wait, and then, so you were also talking about taking strings of parentheses. I sort of got lost with how many parentheses do you have, and how many numbers are there?
Mm-hmm. So yeah, I definitely would be.
That's like the whole thing with math.
In hindsight, it could have probably been better if I had like been on campus and could have like a blackboard or something behind
Finian
me.
will do a Manum representation of this and put it on the video.
I will not.
Yay, Finian.
But so let me try and think of a little bit of a better way to describe this. But like, so if you have, okay, so if we were thinking about the square, so we can talk about, say you have like a set of 3 elements, A, B, and C.
Okay.
They stay in that order. They're non-commutative.
Okay.
So you don't have to worry about like things like B, A, C, or anything like that. They're staying A, B, C. What changes is the order in which you multiply those. And multiply is kind of a general term. It's just you're performing an operation between 2 of those elements, and you can only be performed on 2 at a time. And so one option is that you could first multiply A and B, and then take that quantity and multiply it by C.
Mm-hmm.
And the other option is that you could multiply B and C, and then take that quantity and multiply it by A on the left. Mm-hmm. So that's where you're delineating the parentheses. It's just like an order of operations, basically.
Okay.
And as soon as you add another one, as you add a 4th element, you're going to have 5.
AB.
5 ways.
It's like A, B, B, C, C, D. Right?
Okay.
And then
well, yeah, like you jumped up, but yeah.
Okay, so you have a sequence of some. Is it? Would you say it's n numbers or n elements?
So n. This is what I've also found when doing this research, is that depending on what you are using n to denote, it can get a little bit confusing. Mm-hmm. But like, yes, if we're talking about a sequence of n elements, then you're going to have a correspondence with a polygon that has n plus 1 sides.
Got it. Because the number of ways in which you can multiply do the order of operations on a list or string of n elements is related to the number of ways that you can triangulate in n plus 1 n-gon.
Yes, exactly.
And these are both related. I keep on forgetting the name of that sequence.
Yeah, these are both. Both of these are related to the Catalan numbers.
Okay, the Catalan. I'm going to write that down.
Yeah, there are like hundreds of these different interpretations of Catalan numbers. There are hundreds of Catalan objects.
So they show up everywhere.
2 of them. Yeah, they're like very ubiquitous.
Wait, okay, when you say elements, like if we were just talking about numbers and multiplication, then why does it matter the order in which you do these operations?
Why it matters is a question that I don't concern myself with.
All right, we'll get to that later. We'll get to that later. So, I guess so can you tell us a little bit about where this sequence comes from or where it shows up?
Yeah, so it shows up in these 2 instances. It also shows up in these things called Deke paths, which are named after a German mathematician. And Deke paths are basically they're these paths that are sequences of vectors 1, 1 that can't cross the x-axis when you go back. They're 1, 1, and 1, -1. So you're basically like moving up, and then you could move down and over, but you can't cross the x-axis, and you can move up and over, and you can make these little like strings, these little like zigzags, basically. And I don't know very much about these Deke paths. It's kind of the next stage of where my research is going to go, is looking at these and their connections. But what's like important about like all of the different interpretations is that because they're all related to the same sequence of numbers, there must be some bijection between any 2 of them.
And bijection, do you mean like a relation, or
yeah, what does that mean? So a bijection in particular is basically a mapping from one interpretation to another that has to be both one-to-one and onto, injective and surjective. That's why it's called bijective.
Oh, I learned about that. No way.
Yeah, so that comes up, and that is like using something like a bijection can prove things about uniqueness. Is one of the things that I've been working on. But like it just means that there are ways to go from something like a string of 3 elements and a triangulated square that maps one thing to one thing and only that thing.